Hello, my name is Mike Kistler, and I'm a product manager on the Azure SDK team working on the Azure SDK for Go. Today I want to show you how to use the AZ Service Bus module of the Azure SDK for Go to send and receive messages with an Azure Service Bus message queue. First, I'll give a quick overview of the Azure Service Bus service. There are a few common scenarios for using Azure Service Bus. One is just basic messaging, meaning that you have two components in your application that are running independently, and you need to send information from one to the other. Another common scenario is to decouple applications, typically into some kind of producer and consumer structure. The producer will create work items and then pass them to a consumer to process. But the producer and consumer don't have to interact directly, which can simplify their design. Another scenario is to allow the producers to scale independently from the consumers based on the resources required for each. If your application has any of these requirements, then the Azure Service Bus might be a good fit. Next, I'll describe the basic concepts of the Azure Service Bus. A namespace is a container for all messaging components, queues, and topics. Multiple queues and topics can be in a single namespace, and namespaces often serve as application containers. Queues provide point-to-point message delivery from a sender to a receiver. A message is simply application data in whatever format the application chooses. Service Bus treats the data as just a raw sequence of bytes. Topics are another mechanism to send and receive messages, but here the receiver subscribes to topic messages, possibly filtering based on the message content, or using an action to modify message metadata. You can find the full documentation for the Azure Service Bus service at the link shown here. This slide illustrates the queues and topics concepts of Service Bus. With a queue, a sender puts messages into a queue, and a separate receiver process takes messages out of the queue. Queues provide a simple point-to-point style of messaging between one sender and one receiver. Topics and subscriptions provide a one-to-many style of communication. Receivers use a subscription to select messages to receive from a topic based on the message data and metadata. Service Bus will deliver a copy of the message to all receivers whose subscription filter matches the message. Service Bus stores messages for both queues and topics in durable, triple redundant storage to ensure that a message is not lost before a receiver or all receivers, in the case of topics and subscriptions, is able to receive it. Azure has three closely related services that provide messaging and eventing features. Azure Event Grid and Azure Event Hub both work with events, which differ from messages in a subtle way. A message is raw data provided by a service to be consumed or stored elsewhere. The sender of the message typically has an expectation of how the receiver will process the message. An event is a lightweight notification of a condition or a state change. The publisher of the event has no expectation about how the event is handled. The consumer of the event decides what to do with the notification. Azure Event Grid provides a push-style event delivery to subscribers. Event Grid events are often used to trigger serverless applications. Azure Event Hubs is a big data streaming platform for ingestion and replay of an event stream. It can receive and process millions of events per second. It facilitates the capture, retention, and replay of telemetry and event stream data. You can find more information on Azure Event Grid and Azure Event Hubs in the Azure documentation. Next, I want to show you the documentation for the Azure Service Bus Go SDK. You can find it in the package.go.dev site by searching on the module name AZ Service Bus. You can expand the README section to see information on how to install the package, the prerequisites for using the package, and how to create a client and do the initial authentication with the service. There are also some examples for the key usage scenarios, like sending a message to a queue or topic, and receiving messages from a queue or subscription. You can flip to the documentation section to see the full set of functions and types in the package.
Now let's dive into a demo of how to use the Azure Service Bus from a Go program using the Azure Service Bus Go SDK module. I'm going to start with an empty project. I've got a few VS Code shortcuts in here that will help automate some of the repetitive or less interesting parts of the demo. And other than that, just a license and README file. So let's start by initializing our Go program. I'm going to call this Azure Service Bus demo. All right, and next I want to go get the module, and I'll just get the name of that from the documentation over here. Go get, and this will go get my module. All right, now we'll start with a new file, main.go. So we're going to do some imports, and the key import that I want to do is the package that I just got. So conveniently that's still in the clipboard buffer. And now we're going to create some variables. The first variable I'm going to create is a connection string, which I'm going to get from the environment, and I've already set that in the environment in a variable called service bus connection string. And then after that, I'm going to want a client, and that's going to be coming from the Azure Service Bus package called client. Next, we'll need an init method. And in init, first we're going to need an error. And then we'll just create that client. And here there's a couple of things that we could use. New client and new client from connection string, and I'm going to use the new client from connection string to start. And you can see that it takes a connection string and a client options, and in this case I don't need any client options. So I'm just going to pass connection string, comma nil. And then I need to check that error to make sure that everything went okay there. Now what we're going to be writing is a command line utility. So I'm going to have a little usage function here that I'll be able to print when I haven't gotten the right input. So here's usage, and you can see that I'm expecting the program name, and then the first argument will be either send or receive, and then the second will be a queue name. All right, and now let's just create a main. And this is basically going to get the arguments from the command line and make sure that we have at least one. And if we don't have at least one, then it will print a usage statement. So let's save this. Looks like we have one problem here. Where's that problem? Yes, we're not using that client. That's okay. So now let's go ahead and build. And we'll run our program. And we get our usage statement. So that was what we were looking for. Now we're going to have to build out the rest of the program. So we're going to switch on that first argument that we're getting here, the send or receive, and depending upon which one it is, we'll call either the send or receive function, and otherwise we'll print the usage statement. So let's build out those send and receive functions. These are going to accept an argument array, which is an array of strings. And the first thing that I'll want to do here is make sure that we've gotten at least one argument there. And then I'm going to take that argument and put it into a variable called QName. Now I've got that. I want to create a sender client. So I'm going to call that QSender. And I'll create that from client new sender. And you can see that QSender, new QSender, will take a queue or a topic and options. And once again, we don't actually need any of those options, so we'll just pass the queue name here and nil. And we'll check errors. Next, we're going to read the body of the message from standard in. So I've got a little snippet that will do that. This is just going to read standard in with IOUtil read all and put the result in byte buff or give me an error. So we'll check the error. Now we're going to want to take that byte buff and turn it into a message. So we're going to create a variable called message, azservicebus.message, and we'll put that byte buff into the body. Now we're ready to send. So we'll call QSender dot send message, and send message takes a context and a message. So the context can just be context.todo, and the message is the message that we've produced, and it automatically added the ampersand there. Now this is going to return an error, so we should make sure to check that. So we catch that error and we add the checking there at the end. That's our send function. Now we want our receive function. The 2 is going to take an array of strings, and we'll be doing this same code for receive. And now we're going to want a receive client, and we do Q receiver AZ Service Bus dot, oh actually I'm sorry, not AZ Service Bus, it's going to come from the client. It's going to be client dot new receiver for queue or new receiver for subscription. We're going to be receiving from a queue. And here we need a queue name and options. Queue name and the options, we'll just use the default, which is nil. Check for errors. Now we have a receiver. What we'll do with that receiver is we'll receive the messages from the queue. So we'll say messages queue receiver dot, and we have a few options here. We'll just take receive messages, the simple case. And receive messages takes a context, a maximum number of messages, and then message options. So the context can be our standard to-do context. We'll just receive one message, and we don't need any special options. Now the red highlights here are telling me that I needed an error here. So we'll check for error. And now messages, you can see, is actually an array of servicebus.received_message. And it might have no messages in it because it could be that there were no messages to receive. So first we'll check if len messages greater than 0. And then since we only asked for one message, we know there must be just one message. So we'll take messages sub 0. Now to get the data out of the message, we're going to look for its body. So we'll take body message.body. That looks good. And now we'll check for error. All right, now we have the body. The body is an array of bytes, and we can now just print that. First, making sure we convert it to a string. All right. And it looks like we have no errors. So now we'll try to build again. Okay, now let's try echo which we're going to pass into the program through standard in. We're going to call Azure Service Bus demo. We want to send this message. We're going to send it to a queue called demo. So there we go. And now we'll get to see if this actually worked by asking Azure Service Bus demo receive from this same queue. And sure enough, we get our Hello Gophers message coming back to us from the Azure Service Bus. So what we've seen here is a very simple example of a program that connects to the Azure Service Bus service in Azure. It then sends a message to a queue, and then it does a receive from that queue and gets the message back out and sends it. A very simple send and receive type pattern that you might have in a producer and consumer type application. Now, let me show you a little something interesting that I discovered as I was building this demo. Let's try and do this receive again. Well, what do you know? We got our same message back. That was a little bit of a surprise to me, but it turns out that this is an important feature of Azure Service Bus. And to understand why this is, let's go back to the documentation and we'll have a look at that receiver client. And in the receiver client, you can see that we were calling receive messages, which will receive a set of messages, but you see some other methods on here like complete message and abandon message. And if you go to complete message, you'll see that complete message completes a message, deleting it from the queue or subscription. So what that means is that the message, when we receive it, doesn't actually get deleted until we say complete message. This is actually a feature of Azure Service Bus because it ensures that messages don't get lost. Now let me show you how this works. We'll come back to our program, and after this, we'll call queue receiver dot complete message. And you can see that it takes a context and a message and returns an error. So we'll send it context.todo. We'll give it our message, and we'll catch that error and check it. All right, we'll build again. And we'll receive again. And you see we got that message back, but this time we got it back and we completed it. So now it's gone from the queue. So if we do another receive, there's nothing there to receive. So this receive will sit there until it times out, which is about a minute. And then it'll come back and say there were no messages in the queue. So again, the point of this is that the messages, when they are put into the Azure Service Bus queue, can be received by a receiver, but they aren't immediately deleted until the receiver acknowledges that not only has it received the message, but has also processed it. If the receiver decides that it doesn't want to process it, it can use that abandon message method and say, I want to put it back on the queue and let another receiver process it. Otherwise, it will issue a complete message, show that it has done processing it, and it will remove it from the queue. And if neither of these happens within a certain timeout period, which by default is about 30 seconds, which was why I was able to receive it before, then the message is automatically unlocked for another receiver to receive it. This is sometimes called at least once processing, because Service Bus will make sure that at least one time that message will be processed. It's possible that it could be processed more than once, but it will be processed at least once. Now, the next thing I'd like to talk about is how you might find how many queues or what queues are available in the Azure Service Bus for your application to access. If you come back to the documentation, you'll see that we have clients that can do batches and receiving and sending, but what you'll find is that there's no actual way in the set of base functions in Azure Service Bus to find out which queues are out there for your application to use. Now, it turns out that you can get there. You have to come all the way down to the bottom into this directories to find the admin client. And so if you click here, you get to a whole new package underneath AZ Service Bus that is the admin client. And within the admin client, you can create a new client, and you can do things like listing all of the queues that are available in your Azure Service Bus, list queues. So I'm going to show you how to do that here. We'll come back over to the program, and we'll add a new option into our case. And list, let's just call list. And list doesn't actually need any arguments. We'll come down here and func list. Now list is going to use a different type of client. So we'll create admin client. And we'll call admin new client, and we'll call new client from connection string. And it will take a connection string and client options. So we'll pass our connection string, And we don't need any options. We'll check the error. And now that we have our admin client, we can create what's called a pager for the queues. So we'll create queue pager. Admin client dot list queues. And list queues simply takes a list queues option. We can take the defaults there. And now I have another little snippet. This is actually a very handy feature of VS Code, where it will let you fill in the particular items here, right? So we have queue pager, and what we want to do is for each of these, we're going to print item dot queue name. All right, looks good. Let's give this a try. No problems. So we'll do AZ Service Bus Demo list. Well, that isn't what we were expecting. We were expecting list to show us at least one queue, but it turns out it didn't show us any. So something must be wrong here. Let's try to find out what's wrong. So what we're going to do is I'm going to show you how to set up a little launch program in VS Code so that we can debug this. So we'll go over here to run and debug, and we'll create a launch.json file. Now a launch.json file simply runs our program, and we want to run our program, and this looks pretty good. The one thing that we need to add is, not there, we need to add some command line arguments because we want to make sure we go through the list path. So we've got that, and now we can come over here and let's set a breakpoint right here, and we'll see what happens. So we've got our launch package here, and we'll say let's run that. Start debugging that. So VS Code will set us up, start debugging. And now we've stopped here. So we've gotten to queue pager. We see that error is nil. Let's look at queue pager and see what it says. This looks fine. So let's step. And now what's happened? Well, now you can see that actually in our queue pager, we have an error. This says that we're unauthorized. Why would we be unauthorized? Well, it turns out that the admin client actually needs more than just the regular connection string. Service Bus has read and write capabilities for clients, but then there's another special level of access that you need when you want to access the admin capabilities. So let's stop this, and we can go back to our program and come up here and say that we want the Service Bus admin connection string. Now, I had anticipated this and already set this in the environment, so we should be good to go here. So let's come back here and do another go build and see what happens this time. This time we get all of our queues listed out. So what I've showed you here is that we can get to see the queues that are available in Azure Service Bus. And in addition to seeing the queues, there are many other capabilities here where we can create queues and update queues and create topics, things like that. Those are all capabilities in the admin client. But the admin client does require an extra level of capabilities. So you want to make sure that you have that set if that's a feature that you want to use in your application. Now up to this point, we've been using connection strings to authenticate to Azure Service Bus. Connection strings are an easy way to authenticate, but there are other and in some ways better options for authenticating, particularly for production applications. One of these is Managed Identity, which provides an identity for an application to use when accessing Azure resources without explicit credentials. Eliminating explicit credentials is important because it prevents inadvertent exposure of these credentials, such as in source code checked into GitHub. So we'd like to use this type of authentication, but Managed Identity requires a special environment, not something you can just run in your development machine. So Azure introduced the default Azure credential. This is a feature of Azure Identity library, and it's a special case of a chained credential. Let's go to the documentation. This is the AZ Identity package. And we can come down here and we see that default Azure credential is a chained credential which looks first in the environment and then looks at Managed Identity and then finally looks at what we call developer authentication using the Azure CLI. So let's see how we can actually make this work in our program. We'll come back up here and we'll take the package. We'll go get that into our application. And we'll import that into our program. Now, instead of new client from connection string, what we're going to want to do is we're going to first create a default Azure credential. AZ Identity .new default Azure credential. You can see that the options here are just credential options. In this case, we'll just pass nil. Check for errors. And now, instead of new client from connection string, we'll call new client. Here we need the fully qualified namespace that we're going to be connecting to. So let's come up here and we'll say that we have a credential AZ Identity default Azure credential, and our namespace will be Service Bus namespace. We'll pass the namespace in. And now we need our credential, which is a token credential. The default credential actually inherits from token credential, so we can use that. And then we pass nil. So now we'll be using the default Azure credential, but we're not running in a managed environment. So we're going to need to sign in with the Azure CLI. Now we're going to be using Azure CLI authentication. Let's talk about the Azure CLI for a minute. The Azure CLI is a command line application you can install on any Windows, Mac, or Linux system that lets you access nearly all the different resources of Azure. I've already got it installed on my system here. We'll be using our CLI credentials. I've got the Azure CLI installed on this machine. You invoke the Azure CLI with AZ. And you can see here that we've got AZ installed. And we're up to date. So if we just try running this, and we'll bring up our send to our demo queue again. Here we see that we don't have access. It turns out that our CLI client, by default, doesn't have access. So now we need to understand a little bit more about how RBAC works, about how Azure Default Credential works. This slide gives a quick overview of the Azure Role-Based Access Control, or RBAC system. There are three basic components in RBAC. The first is a role, which is just a collection of actions that the assigned identity can perform. A role could be scoped down to a single action, like read from a service bus queue, but often is a collection of related actions with a meaningful name. Next is a service principal, which is an Azure identity of some type. This could be a user or a group or even an application that has been assigned an identity. The third component is a scope, which describes a set of resources. A resource group or a subscription are a few ways to specify the scope for RBAC. These three components are combined to create a role assignment, which assigns a role to a service principal in a scope. We're going to use the Azure CLI to create a role assignment for our CLI user that will allow it to send and receive messages on our Azure Service Bus message queue. First, we need to know what role or roles to assign. Each service defines a set of built-in roles, and you can also have the ability to create custom roles, custom groups of actions for which you want to assign permissions. The built-in roles are going to be fine for our purposes, and one place you can find these is in the Azure portal. Here you can see I'm on the page for my Azure Service Bus namespace, and in particular the demo queue, and you can see that on the access control blade in the roles tab there's a list of roles, and there's a set here that are particularly useful. There's Azure Service Bus Data Owner, Azure Service Bus Data Receiver, and Azure Service Bus Data Sender. And Azure Service Bus Data Owner gives us full access to all of the resources, and so that's the one that we're going to use. So we're going to take this and store it away in a variable. Next, we need to know our service principal. Fortunately, we can get the service principal for the current CLI user from the Azure CLI. There's a command called azad signed in user. and we want to show the result of that. And in particular, we want to see query user principal name. So that tells us our user principal name, and you can see that it looks like my email address plus some additional information that's tacked on to the end. So we're going to save that away. We need to strip out some of the extra decoration on it. And we're going to put this in a variable called SP. Now lastly, we need the scope. Here again, we can use the Azure CLI to see attributes of our Service Bus namespace, in particular, the scope for that namespace, which is in a variable called ID. So we say AZ Service Bus namespace list. Now this will give us a list of the namespaces. We actually only want the first namespace. There's only one namespace active, but we want to get to the first one, and then we want to show its ID property. So that shows us the scope for our Azure Service Bus namespace. So we'll save this in a variable. Now we have all the three pieces of information that we need in order to create a role assignment for our logged in user to our Azure Service Bus namespace. So we do that with AZ role assignment create. And we'll use these bits of information that we've stashed away. The role is the role. We say assignee is our service principal, and the scope is $scope. And it looks like it's created that role assignment, which is great. So now let's see if we can go back and now do our send onto the queue. It looks like it worked. Let's see what we get back. Receive, demo. And there we go. What we've shown now is that we can use the default Azure credential with the appropriate RBAC permissions set up to be able to access our Service Bus queue. And we can now use that from our development environment by signing in with the Azure CLI. And we can also use that in our production environments using either managed credentials or environment variables. That's the end of the demo on Azure Service Bus. I hope you like this. Thank you very much.